Recruit some help. Maybe those guys in the back, possibly. Ready, set, go! Hi. Zach, I turned it off. I don't know why it's doing that. Everybody has that? Yeah. They don't.
You can guess it, right?
What's that?
They can guess it and they got it right.
Really?
And they got it right.
Hey. Stop letting me get it. So what we're going to do, we're going to chalk this up to first day glitches. We're going to retry this because about a third of you can't get in because of the little second coding thing. So let's try this again. And so this two-step join is off. So let's try to rejoin. Let me know if you still have to do the two-step authentication. So it might be a new pin. It's a totally new pin. Sorry, like I didn't want a third of you just sitting there not participating. So is this good? No second step needed. All right. You gotta have to move units, right? Hey guys, have you figured out that the numbers or the letters are all jumbled?
Yeah.
Okay. Just making sure.
Hopefully that's a problem.
We'll find out. All right, question 4. Yeah, look at the next one.
Yeah.
Got about 20 seconds. Time to guess. Hey, that's better. Try question 5. Last 30 seconds. Probably time to make an educated guess. There's your leaderboard. Put your motive in need to use local rules. 30 seconds. Okay. There we go. This took forever. I don't understand why. All right, question 7. Here we go. You're on the back stretch, second half. Sorry, we were in full screen. Integral of x squared times cosine of x cubed. Thank you, Sammy. All right. Good. Rachel is killing you guys right now. All right, here we go. Question 8. What's that? You need to go? Do some more coloring. Hey, do you want Play-Doh? Oh my goodness. Not so good. What was that one? Oh, the natural log. Okay, they probably forgot the 3. All right, here's your leaderboard. Johnny is catching up. Question 9. That last one, that was number 8.
That's just how my knee.
Actually, can you see it here? I can go up. So, you might not know, like, we're going to do some of the, I don't know, stuff that can be, like, 2 sharing questions. If you look at the sharing question, you like, correct answer was C. Nope. About time to guess, you got 5 seconds. All right, down to our last 2. Number 11 next. This one carefully. All right. Riley has the lead. One question left. Here we go. Every last 10 seconds. Second guess. Good. Ashley. Maya. Johnny, was that you really? Johnny? Johnny, was that really you?
It was really Johnny.
Good job, Johnny. And let's see here. Riley, was that really you? You? Who's Stalinade? I like it. Okay, good. Hey, hey guys, listen up. So as we were going through those, there were maybe like 4 of them or so, where the results were pretty low. So want to go back over those. Two.
If she's actually close, but like.
Hey, could one person sign in real quick? I just need one. So guys, number two had some struggles. Hey guys, listen up. So number two, when you look at this one, integral from 0 to 1 of e to the negative 4x dx, what I noticed is that either the u substitution or the adjustment that we made was not good. I would look at this, like in my group we call this like Timmy messed up the chain rule. And so I would look at the inside, which is right here, and recognize that the derivative of the inside is negative 4. Here's where we sometimes get lazy. What we want to do is we want to multiply the inside by negative 4, which means we have to multiply the outside by negative 1/4. I think sometimes that's where we get lazy. We don't put both. We just try to skip that step. Instead of doing both pieces, we just do one. You could do the full u substitution if you want. This ends up being negative 1/4 e to the negative 4x when you actually do the antiderivative, evaluated from 0 to 1. Then the next step is this. Aren't you guys used to the idea that when you plug in a 0, you just get 0? Not true here, right? Because you have an exponential. So when you plug in a 1, you get negative 1/4 e to the negative 4th. And I think that was a pretty common answer. I think a lot of folks answered A. So if you did answer A, you basically just ignored the 0. So if you actually put the 0 in there, you get minus negative 1/4 e to the 0. And e to the 0 is not 0. It's 1. So you end up with negative 1/4 e to the negative 4 plus 1/4. Because minus a negative is plus positive. That makes sense? So I feel like that's something that you probably know how to do, but you either going too fast or maybe a little bit careless on that one. So anyway. So number 3. So hey guys, listen, was it D that people answered a lot of? Or no, B? Oh, okay. So here's what's going on here. Listen up. If you answered B, which I think the vast majority of you did, what you're doing is you are mixing up vertical asymptotes with horizontal asymptotes. So if it told you that the line x equals 2 was a vertical asymptote, then sure, maybe B is right. But if you think about what a horizontal asymptote is, horizontal line y equals 2 is an asymptote. Horizontal asymptote is basically talking about long-term behavior. So you can have some graph y equals 2 would be right about here. Let's say that horizontal asymptote, you guys realize that a graph can actually cross a horizontal asymptote multiple times? A graph cannot cross a vertical asymptote at all. Right? Because if a graph could cross a vertical asymptote, that means that you just figured out how to divide by 0, essentially. You can't do that. But all that a horizontal asymptote is describing is long-term behavior. So if it says that y equals 2 is a horizontal asymptote, that means as you approach either or both ends, the graph maybe could look something like this. It's going to be approaching that value, right? It's going to get closer and closer and closer to the line y equals 2. And it could cross it. I mean, honestly, it could cross it 100 times, or however many times that is, and it's still a horizontal asymptote. A horizontal asymptote is simply describing the long-term end behavior, not like a vertical asymptote saying you can't go there. It's not saying that at all. You actually can go there. It's just describing the far right end or the far left end. So that tells me that the answer has got to be E, because as we go to the far right end of f of x, we're approaching a y value of 2. That's what a horizontal asymptote is. Follow-up questions or no? Julia, did you have a follow-up? So you're good? Okay. Okay. So guys, number 5. Let's see here again. I have a suspicion this probably has to do with the 0. Because I feel like anytime we see a 0, we're like, cool, second term won't be there. But if you're dealing with exponentials and trig functions, it could be there, right? Could be something other than 0. So with this one, you would say that the antiderivative of sine is negative cosine, evaluated from 0 to pi over 4. Then you plug in your pi over 4, so it would be negative cosine of pi over 4 minus negative cosine of 0. Unit circle time, of course, you're going to have to do that here. Cosine of pi over 4 is root 2 over 2, so this would be negative root 2 over 2. Cosine of 0 is 1, so plus 1. So it's right above it, D. So again, be careful with the 0 stuff. Don't assume that that's just going to make the second term go away. Sometimes it does, sometimes it does not. Last one was 8. And so then on number 8, gosh, I don't remember which answer was picked the most. So here we go. It wants to know f prime of 0. So you got to find f prime of x before you plug in the 0. So find f prime first, then plug in the 0. So we would say then f prime equals, the derivative of natural log of something is 1 over that something but then we have to multiply by the derivative of the inside. So this would be 1. The derivative of 4 is 0. And then what do you have to use on the derivative of that last term? Got to use the chain rule. So it's going to be minus 3e to the negative 3x when you multiply by the derivative of the inside. Once you've done this, you plug in a 0. So f prime of 0 equals, let's see here. 0 plus 4 is 4. Looks like it's going to be 4 plus 1. So that's 5 times 1 minus 3e to the 0. So I'm getting negative 2. So I'd go with A. Again, I don't know. I guess I didn't write down exactly which one you guys answered with. Do you guys have any follow-ups on this one? Had to have been some little detail in there. Oh, sorry. There we go. Okay, what do you think? Good? Okay. All right. Okay, so there are your answers. Please take 2 minutes, look those over. We'll do some Q&As on whatever it is you want to think about. Hey. See all these kids are working on? Like you do your numbers and this is if you want to, you certainly can. Like if you don't have any questions. Hey, guys, you all had a chance to kind of go over this, looking at the answers and such. I would strongly encourage you to try to grade yourself, and you come up with something and you're not sure how you should grade yourself, that can actually be a really good conversation point for what you should have done or why it's graded a certain way or whatever. So you can ask about that. You can just ask strictly about content, whatever it happens to be. So if you want to talk about this, feel free to raise your hand here in a second. If you just want to move on to number 2, you feel free to move on to number 2. No big deal. Question? Yeah, right. C? Yeah. So for C, it's a little bit different, right? Because it asks you to split it up into 2 equal areas. So let me get back to this. Yeah. Hang on just a second, okay? So Riley, for C and others, I know C definitely was tough. It says the vertical line x equals k divides R into 2 regions with equal areas. And so I guess what I would maybe do here is just try to illustrate that just to help me kind of figure out basically what I'm doing. So does that seem reasonable for x equals k? So I'm just going to throw that in there and say roughly that-ish would divide this region R into 2 equal regions. And so then what I'd be dealing with would be what I'm going to call the purple region right there and the red region over here. So if I could express those 2 regions using, like it says, using integrals, then maybe I could come up with an equation. So what I'm going to try to do here first is come up with an equation for the area of my purple region. So I would say my purple region is going to start at 0, and it has to end at k, right? Wherever k is. We don't know where, but it's got to start at 0. It's got to end at k. And the area is going to be that basic high minus low concept. And so I would go high is 4. Minus low. And did you guys notice they probably used f of x's instead of the whole thing? So Emma, I'm thinking about like the conversation we had, and I would say this to everybody, instead of writing the whole rule for f of x, if f of x is defined to be the thing you want it to be, just write f of x. That way there's much less of a possibility of messing up with parentheses. So what I would say here, Riley, is that's the area of my purple region, my proposed like left half. And then my right half would be just basically starting at k and ending out there at the right edge. What was the right edge, right intersection point? Okay, that's right, yeah, 2.3. But it would still be the same representative rectangle, right? We'd still have the high being the horizontal line and the low being the function, the curvy one there. So it'd be 4 minus f of x again. And so if I set those 2 equal to each other, this would be an equation in which the only real variable, once I did my antiderivatives, would be k. This would be an equation that if I took it all the way through and went to the pains of finding antiderivatives and such, I could solve it to eventually find what that k would need to be. Does that make sense?
Yeah. Would this work too? Just like saying that purple equals the whole thing times 1/2.
So you're okay. And you have r of x right here? What does r of x stand for?
The area of the region.
Got to be careful because you're doing the integral of the area.
Mm-hmm.
That's not going to be the area.
Okay.
I think we could.
If we didn't use the r thing.
Yeah, so we could do it a little bit differently. So we could say, you could do this. Hey guys, here's an alternative, which I think is great. You could say, integral from 0 to k of 4 minus f of x dx equals the integral from 0 to 2.3 of 4 minus f of x dx times 1/2. Right? Does that make sense? So you could just take the whole thing, multiply it by 1/2, and say, that, okay, that should be equal to 0 to k. And that would give you, so that, I think that's kind of what you were going for.
Yeah.
Just be careful with your integrand, right? Okay. Okay, yeah. Yeah, there's, guys, a lot of times there's alternatives like this. You might have been thinking about it like this, And the people that made the answer sheet were thinking about it like this, but we both might end up at the same place, so it could be okay. So don't be shy about asking if what you have is okay or not. Okay, what about anything else? A or B? Any other thoughts on this one? You all look like you've moved on to the second one, possibly. Like I said, if you have any questions about scoring, I think sometimes that can be a really insightful thing for you to understand, like why it's scored the way it's scored. If you have a question about propagated error, some of them I could give you a definitive answer. Others, it would just be a kind of a best guess sort of an answer. So, all right, if you haven't moved on to number 2, looks like that's where we're at. So go for it. Here are your answers with points for the second one. Did you guys look at this one?
Yes, we did it.
D presented some challenges.
It was a bit of a struggle, but I think
Okay.
we understand.
Okay.
Yeah.
So, hey guys, let me just get some feedback from you on this one. A. Any questions on A? How about B? C? Is it all about D? No? Yeah, you want to talk about D? Okay. Anybody need more time with this screen? Any more time with this screen? I'm going to switch over to the other one. Okay. So let's take a look at D. Oh. Sorry, Julia, I thought we were ready to switch screens, but I don't think we are. What's up?
D, why is it 3 plus the integral of 1 to...
I think there's a number of ways you could approach D. But if you go in order, it says write an expression for f of x that involves an integral. So this is like a very non-contextual question, right? It's not like an application. Like we've looked at questions like this that had to do with like position and displacement and total distance traveled, things like that. The net change of water in some water tank, whatever. This is like very not contextual, so in some ways it's harder to visualize and think about what it's actually doing. But it's basically using the y-coordinate as kind of a contextual thing, like the water tank, the amount of water in a water tank. The y-coordinate is like that. So it says write an expression for f of x that involves an integral. So if you write, you got f prime right here, and you're going to be using an integral. So if you were to say integral from 1 to x of f prime of t dt, this you obviously saw this as part of what they wrote. Could you guys describe what that is? Integral from 1 to x of f prime. Say again? Okay, it kind of is, yes, but what does it mean for f? Like, what is this describing about f? Okay, and that is? I'm looking for like a specific term here. Yeah, from 1 to x. Let me put it like this. If you do wouldn't it be fair to say that this right here, that's a rate? If you do the definite integral of a rate, what do you get? Amount of change. Don't just say amount. It's amount of change. So this right here is the amount of change that f will experience as you integrate from 1 to x. That's the amount of change. So that does not mean that the result of this will be the y value. Doesn't the y value depend on two things? Doesn't it depend on the amount of change as well as where it started? So where did the y coordinate start? I know, it's a distraction to me too. 3. Thank you. So if you go plus 3, this would give you an expression for f of x because we have where the y coordinate started, which was 3, and we're adding to that the amount of change. This would be one way to look at it. And I'm not saying that this is the only way to look at it. It's one way. So if you said f of x is that should lead us to a good place. It's not the only way to do this. So then once you've done that, if you were going to find f of 4, you would say f of 4 equals the integral from 1 to 4 of f prime, and then plus 3. As I walked around, I don't know what you saw, Mr. Lothar, but as I walked around, I noticed that we were struggling a little bit with the 9 and the 12. Remember that if an area is below the x-axis, it will integrate as a negative. So this would be a negative 9 as you integrate. This would be a negative 12 as you integrate. So I saw some folks that were forgetting that those would actually be negative accumulations as opposed to positive accumulations. So be careful with that. We can look at this in other ways. Do you have follow-up questions? Anything I can do to help make this more clear? Hi, Avery. How you doing?